Alright, so now back in Afghanistan, back here at Ganbury, taking a second look at the bottles that we have. So what you can see here on the left are the 4 bottles that were filled up at Gardez, elevation 7,700 feet. And then over here on the right, we've got 4 empty bottles. These kind of represent our standard. This is what the bottles looked like when they were filled up, about the same size. So here on the left, the bottles that came from Gardez, you can see that. I'm going to pan around a little bit. You can see bottles have been crunched, different, a little bit different one for some of them, but kind of different sizes, a little bit smaller. So the question now is, how can we measure the volume of these bottles over here, these ones on the left? And that's something I'll leave you to think on. Alright, so here we are, we've got our 2 sets of water bottles. So what kind of ideas did you come up with? So one thing we could do, if we look at these bottles over here to measure the volume, we could, well, let's take a look at these ones here on the right. So these ones, so the bottles themselves are 500 milliliters. And so that pretty much tells us kind of, for these over here, what the volume is. But if we wanted to be more precise, we could measure the circumference, or measure the radius, and calculate volume that way. But these ones over here, they're crunched down. So we know that they're going to be less than 500 milliliters. But just looking at it, there's not really any way that we could tell. In measuring, we could try and do that, but it would be kind of difficult. Fortunately, one of the advantages of water, what was in them, is that it's incompressible. And so if we start thinking about buoyancy, if I take this and dip it in water, the amount of water that it will displace or push out is equal to the volume of that object. So we can kind of use that to figure out what the volume of that bottle is. Of course, the one challenge is, here in Afghanistan, I don't exactly have a way to accurately measure certain volumes, and I don't really have a contraption set up to do that. So, what I'm proposing to do is I'm going to take this larger water bottle, cut it up, basically make a container, fill it with water, and then dip those into that, using this styrofoam tray to catch and all the water that spills out, which represents the volume of water, and then kind of go from there. We'll see how this works. We've actually tried it before, so this should be interesting. Alright, already gotten started, but go ahead and finish kind of cutting this up so you can see what this works. The idea is that I will fill this up as far as I can with water, and then by adding this, it will displace the amount of water equal to the volume inside of that. Now I'll catch the water in this styrofoam container, and we'll go from there. Alright, we've got our water container filled all the way up to the very top. Now we're going to see how much water gets displaced. We'll start with one of our standard non-compressed 500 milliliter bottles. If we did this right, it should work out to about 500 milliliters. Alright, so here we go. 500 milliliters non-compressed. Push it in, and we see that it starts displacing water. So we push it down until we get to the top. And then we'll take it out. So, we did this right. The amount of water that's in here is equal to the volume of this. Now the question is, how do we figure out the volume of water that's in that container? Let you think on it for a second. Alright, so we kind of lucked out in one regard, in that, so we've got this bottle here, we know it's 500 milliliters, so we can kind of use that as reference. And then the top from this bottle, it turns out, is just a tiny bit smaller than this bottle. it basically works out as a funnel for us. So then, all that we need to do, we'll see if this works, is to pour this water into there. See, but bottle's essentially full. 500 milliliters of the bottle displaced the amount of water to fill it up. And that's actually what we want to see. And so what we'll do is we'll just put a mark on here, annotating. Oops, a little red. Surprising. A mark on here annotating where the top is. So we have that kind of reference. So that mark there indicates 500 milliliters. So then what we'll do